Hello. This worksheet can be found in Ivy Learn class notes. It is number 4. You should really complete this worksheet and then come back to the video to check your answers and for any additional clarification. So at the top of the worksheet, it is the same information that was on the previous worksheet about how do you know which type of factoring is necessary. Number 1, there is a common factor for all terms of the polynomial. If there is, you need to factor out the greatest common factor. Number 2, you want to look at how many terms you are factoring. And finally, you want to make sure that your factors are all prime. The following examples, I will factor completely. There's a note that sometimes it is necessary to use more than one method of factoring. So let's get started. Number 1 has a greatest common factor, 5x. If you divide each term by 5x, the result will be x plus 3. So your factors are 5x times x plus 3. Number 2, notice that the first term is a perfect square, 3x times 3x. The last term is a perfect square, 2 times 2. The question is the middle term double or 2 times the first term and the last term? And on our notes, it was A and B. So 2 times 3 is 6, times 2 is 12. So we know that this is going to follow the perfect square trinomial pattern. So we have 3x minus 2 times 3x minus 2, or 3x minus 2 squared. If you didn't do it this way, that's fine. You can always use the AC method or another method. Number 3, we want the factors of negative 48 that add to 13. 16 and negative 3 will work. Always multiply your factors back together to see if you get the original. I'll leave that up to you. Number 4 is a difference of perfect squares. So 12x minus 1, 12x plus 1. Number 5, you have 2 terms. They both are perfect cubes. 64x cubed is 4x, because 4x times 4x times 4x is 64x cubed. And the cubed root of 27 is 3, because 3 times 3 times 3 is 27. This will factor into the first factor of 4x minus 3. Then it's 4x times 4x, which is 16x squared. A times b, or 3 times 4x. And 3 times 3 is 9. The signs are the same. Opposite, always positive. Number 6, couple ways to factor this one. If you write it in descending powers of x, since the leading coefficient is negative, if you take out a negative 1, and now you need the factors of negative 12 that add to negative 1. So we could have -1, x minus 4, x plus 3. There are a couple variations of that answer. So you can ask your instructor if your answer is correct, but you again always multiply it back together to make sure it works. All right, number 7. Number 7, we have two terms, but we also notice that they have a greatest common factor. They both are divisible by 6. They both share a variable x. So factor out the one with the smallest exponent. Oh, that's a 3. Now you might notice x squared minus 4 is a difference of perfect squares. And that will factor into x minus 2, x plus 2. Number 8, we'll take out a greatest common factor. They all are divisible by 4. They all have a common variable of x. Take out the one with the smallest exponent. And then we need to see if we can factor x squared plus 6x plus 8. So we need the factors of 8 that add to 6, 2 and 4. Number 9, we don't have a greatest common factor, and we have 4 terms. So we need a factor by grouping. Group the first two, attach the negative inside the parentheses to the 9. Greatest common factor is x squared. The leading coefficient is negative, so factor out a negative, in this case, -9. -9 times x is -9x, and -9 times 6 is -54. So now our greatest common factor is x plus 6. And the other factor is x squared minus 9. X squared minus 9 is a difference of perfect squares. That will factor into x minus 3, x plus 3. So that's what we mean by factor completely. Number 10, they're all divisible by 2. So our greatest common factor is 2. The factors of -16 that add to -6. -8 and 2. So now the trinomial is factored completely. Number 11, greatest common factor, 4 and 8. 4, they share a variable x. Greatest common factor is the one with the smallest exponent. Same with the y's. Multiply it back together just to make sure you are correct. And if we multiply 4x cubed y squared times x cubed, we get the first term. If we multiply 4x cubed y squared times 2y to the fifth, we get 8x cubed y to the seventh. Always check your factoring by multiplying. Number 12, we have two terms. We have a minus, we have an x cubed, but 6 and 48 are not perfect cubes. But if we take out the greatest common factor, which is 6, now we have a difference of perfect cubes. So we have the greatest common factor of 6. We factor x cubed minus 8. That's x minus 2 times x squared, 2x, 4, same, opposite, always positive. And those are definitely review from the previous lesson. This next worksheet is definitely practice. If you have not completed this worksheet prior to watching this video, I would tell you to stop the video, work out these 9 practice problems, and then come back and check your answers. Number 1, we have 4 terms. We should factor by grouping. And our factors are prime, so we are finished. Number 2, they share a common variable of x. Take out the one with the smallest exponent. X squared plus 4 is a sum of perfect squares and will not factor anymore. Number 3, we have a greatest common factor of 4. And then we need to see if we can find the factors of 8 that add to -6. -4, -2. So our final answer number 4, 6 and 54 have a common factor of 6. X squared minus 9 is a difference of perfect squares. Number 5, we need the factors of -48 that add to 13. I'll remind you, I made a video on how to use your calculator's table to find the factors of 48. You would put in table y equals 48 divided by x. And we would figure out that -3 and 16 multiply to give you -48, and they add to give you 13. So our factors are x minus 3, x plus 16. Number 6, notice that 4x squared is 2x times 2x, 9 is 3 times 3, and 12x is 2 times 2x times 3. So it's going to follow that perfect square trinomial pattern. So it's going to be 2x plus 3, 2x plus 3. You can multiply that back together to make sure you get the original, or you can write it as 2x plus 3, all of that squared. Number 7, I prefer to do number 7 this way, personal preference. Going to factor out a -1, so my leading coefficient is positive. I'm going to find the factors of -18 that add to -3. -6 and 3. So my factors are x minus 6, x plus 3, but we must have that -1 in front. Number 8. We can factor this using the AC method. We can take 35 times -1. We need the factors of -35 that add to -2. And we can factor by grouping. Take out the greatest common factor. I like to factor out my greatest common factor of 1, because then when I write it as 2 factors, it helps me see that it is 7x plus 1. Number 9 is a difference of perfect cubes. 8x cubed is 2x times 2x times 2x, and 125 is 5 times 5 times 5. Using the pattern to factor a perfect difference of perfect cubes, 2x minus 5, 4x squared plus 10x plus 25. And there you go. That's all we have for now. Be sure to ask your instructor if you have any questions. See you next time. Bye.